So sorry the video cut out on me while we were doing this last problem here, so we'll go ahead and just quickly finish this up. I'm fairly certain you guys were all getting it by that point, but basically square root, bring the 3, get it right here. And the one thing I just realized is that I'm kind of going in depth to a lot of this, while a lot of my classmates in my class already know about this. I'm kind of framing these videos as a way of kind of explaining it to my students, really. So if you kind of feel like, man, he's talking forever, like, man, he's like going on and on about this, just know that my intended audience is for students. So anyway, back to the project here. So basically, that's how we do the breaking down numbers using our cards here, 2, 3, 5, and 7. So that's how we do that. Now, as we all know, radicals come in all different shapes and sizes, and some radicals that we get are radicals of variables. Let's say x squared, and x to the third power. All right. Now, what would we do for these? Well, that is where our other cards come into play. Because as we remember, we had 5 cards of x's, 5 cards of y's, and 5 cards of z's. So we are now going to use these cards in order to simplify our radicals out. So instead of putting like a number down here, I'm going to put just a card of x here. So this is for the first one here. So this is x. Now, the number of cards that I put down is all dependent on the exponent. If it's 1 exponent, which is right here, you put 1 card. 2 exponent, you put 2. 3, 3, so on and so forth. Okay? And again, it's the same idea. It's the same idea as our numbers. We're looking for pairs. Now, as we see here with the square root of x, it's just 1x. I don't have any pairs. What that tells me is that I can't do anything with this. So this can't be simplified. Now let's do the x squared. That basically requires us to add another x card in there. So on our whiteboard we'd have the square root of, and then 2 x cards here. And again, we're looking for pairs, and if you look, hey, you got a pair of cards right there, all right? Pair of x's. And just as it did with numbers, again, these are the same things as it did with numbers. 2 x's on the inside create 1 x on the outside. So what this tells me is that the square root of x squared is equal to x, because 2 x's on the inside make the 1 x on the outside. And what about x to the third power? All right. Well, that just requires us to put 3 x cards down. As I mentioned with that final x to the 3, kind of that final example in the last video where we have the 3 cards right here. Even though these are all the same, we can only pick 2 of them in the pair. So let's just pick these last 2. Doesn't matter. We can pick these first 2. It doesn't matter. But we have 2 x's that we group together to create the 1 x the x on the outside. So actually, let me rewrite this down here. Two x's on the inside creates the 1 x on the outside. We still have this one lone x right here. That x will remain underneath. So what that tells us, when we simplify this, is that this x to the third power, the square root of x to the third power, is x square root of x. Okay? Alright. Now let's just rapid fire through some more variables ones here. So let's deal with the y's. So I have y to the 4th, which tells me I'm going to put 4 y cards down. 1, 2, 3, 4. Looking for pairs. In fact, this time I have 2 pairs. Alright? So on my separate sheet of paper, what I would write is I got 2 pairs of y's. That gives me 2 y's on the outside. And remember, if I have 2 numbers, 2 of something on the outside, I multiply them together. Y times y gives me y squared, which tells me that the square root of y to the 4th is y squared. We move on to the next one. This one's going to require quite a few cards here. I have x to the 3rd power and y to the 5th power. So here, I'm going to put 3 x cards down, and I'm going to put 5 y cards down. Make my square root a little bit bigger here. Okay, so now we're looking for pairs, alright? So, and we have to look for pairs of the same ones. I mean, I can't go and make, pairs of an x and a y. It has to be pairs of the same variables. So when I look, I have a pair of x's here, I have a pair of y's here, and then I have another pair of y's here. So I have one pair of x's, and then I have 2 pairs of y's. And if I were to bring that down on my sheet of paper, remember, 2 x's come together to create 1 x on the outside. 2 y's come together to create 2 y's on the outside that we multiply. And remember that y times y is equal to y squared. This x just remains the same. And if we look, we're left with 1 x and 1 y underneath the square root. We're just going to write those together underneath the square root there. So what that tells us is that the square root of x to the 3rd and square root of y to the 5th is just x times y to the 2nd times xy. And then we do that last example there. And I have a few more cards on this one here. So we're going to have 2 x's, 2 y's, and then a single z. And looking at our pairs, we see a pair of x's, a pair of y's, and we just have a single lone z right there. So it looks like we can't really do much of anything with that. So as we've talked about before, the 2 x's come together, and the 2 y's to come together to create an x on the outside and a y on the outside of our square root. Well, x times y, well, we can't really combine those together, so we're just going to write xy. We don't even need to write like a multiplication symbol there. So we just write xy. Since the z is only a single z, we leave it underneath our square root. So what that tells us is that the square root of x squared y squared times z is going to be xy times z. Alrighty. So now we've gone through how to break down numbers using basically our prime cards method, and then we've also learned how to break down variable radicals using our card method. So let's put it together for these next couple of examples. Alrighty, so now we are going to combine both methods. We're going to use both numbers and variables together in order to simplify down this radical. So if we take a look at this radical, and actually before I do any of that, we're going to list out all of our card options over here. Again, we have 2's, 3's, 5's, and 7's, as well as x's, y's, and z's. Again, pretty self-explanatory. 5 of each. So if we take a look at this radical, it looks pretty gnarly. We got a pretty big number, 225. We got a lot of variables, x to the 3rd, y to the 5th, z to the 2nd. We got a lot of stuff going on here. So on my whiteboard, what I'm going to do, I got my big square root. I'm going to need a big one for this. And what I'm going to do is I'm going to now do my prime factorization. Try to figure out, and let's start with the 225. What cards can we put down from 2, 3, 5, and 7 to get 225? Well, so if we think about it, let's see, 225 seems divisible by 5, so we know that 5 times 45. And 45 can be broken down by 3. 45 can be broken down by 3 as 3 times 15. And again, we know that 3 times 15 is 3 times 5. Okay? So that's our 225 broken down. And then for our x's, x to the third means we have 3 x's. Y to the fifth means we have 5 y's. And then z to the squared means we have 2 z's down here. And just as we did before with everything, we're going to look for pairs. And if we look, we have a pair of 3's, the pairs of 5's, one pair of x's, pairs of y's, and a pair of z's. Go down to my piece of paper, and I see that my 5's together and my 3's together will get me to the outside. If I have 2 numbers on the outside, so 2 5's make a 5 on the outside, 2 3's make a 3 on the outside, and then my 2 x's will come outside. My 2 pairs of y's will give me 2 y's on the outside, so y times y and y. And then my pair of z's will also give me something out there. And then once we get all of our stuff out here, we brought a lot of stuff out here. All we do with this is just multiply it all together. So we multiply the numbers. 3 times 5 is 15. Well, x, there's no other x's to multiply, so x stays the same. Y times y gets us y squared. Z gets us z. And then underneath, we're still left with the x and the y that we'll just put together there. And so from that, we know that this is going to be 15 xy squared z times the square root of xy. Okay? Let's do another example. Square root of 60 times x, y to the fifth, z to the fifth. Let's do the easy one first. Let's get all of our x cards. Let's get all of our variable cards out of the way. So we have, on our whiteboard, we put down one x card, and we would max out our y's and our z cards. So 5 y's and 5 z's. Okay, now 60, trying to break these down with our numbers here. Well, I do know that 2 times 30 is 60, so I know a 2 will be in there. And 30, that is 2 times 15, so I'll add another 2, and then I know that 15 is 3 times 5. And just as I'm looking for, look for pairs. I got my pairs of 2's, I got my pairs of y's, and my pairs of z's. And again, what that's telling me is that, well, my 2's, I'm just going to kind of rewrite everything just as I was writing, just kind of pretend if I was writing it on a piece of paper. My 2 2's come onto the outside to give me a 2, y's, and my z's. Just as I did in the previous problem, I'm going to multiply everything on the outside here together. So the 2 is going to stay the same, the y is going to become y squared, and the z is going to become z squared. Now underneath, we have 2 numbers underneath our square root. If we were to have 2 numbers underneath the square root, we would have to multiply those as well. So I'm still remaining with that 3 and 5. I'm going to multiply those together to get me 15 with the x and the z still remaining. And that right there is my project, is my presentation of simplifying radicals using kind of manipulatives and prime factorization. I will have these 2 videos up on the discussion board as well as the homework assignment attached to it. Thank you.